Here's the parallelogram method for finding sum or resultant of two vectors. For example, two forces of 30N and 50N are acting at a point such that the angle between them is 60 degrees in parallelogram. We draw on vectors that are parallel to the given. Since the angles are supplementary, we subtract 60 degrees to 180 degrees, which equates to 120 degrees. And now, what we're going to do is to find C, and we are going to use the law of cosine to help us. So, the equation is C squared is equal to A squared plus B squared minus 2AB cosine of 120 degrees. And then, we're gonna substitute, and now we get C squared is equal to 50 squared plus 30 squared minus 2 times 50 times 30 cosine of 120. And then calculate, then our final answer is 70N. So, to find the direction, we use the law of sines, and then cross multiply since theta over 30 and sine of 120 degree over 70. And that would give us 0.371. And then you're gonna use the inverse sine and we get 21.8. And therefore, the resultant force is 70 at an angle of 21.8 to the 50N vector.
The polygon method is a method for finding sum of or resultant of more than two or more vectors. In the polygon method of finding the sum or resultant of vectors, the given are drawn from head to tail to form an open polygon. The resultant vector is drawn from the tail of the first vector to the head of the last vector.
Vector addition using polygon method. Vector A, 200 km east. Vector B, 150 km 35 degree north of east. Vector C, 250 km 130 degree north of west. And our scale is 1 cm is equal to 50 km. Here, first we have to plot the vectors in a plane. And then here, in my graphing paper, I have already plotted it. We have to plot the first vector, vector A. And since our scale is 1 cm is equal to 50 km, we have used the ruler to measure it here. And then since it's polygon method, we have to put the tail of the second vector in the head of previous vector, and so on. That's what's going to happen in here and there. And then we have to measure the displacement or the resultant vector here from origin to the head of the last vector. Since it's 6 centimeter, it is equivalent to 300 kilometer. And our direction, we have used this protractor. It's 60 degree north of east. That's it.
Any vector directed in two dimensions can be thought of as having an influence in two different directions. Each part of a two-dimensional vector known as component. The components of a vector depict the influence of that vector in a given direction. The x-coordinate of vector A is called its x component, and the y-coordinate of vector A is called its y component. The vector x component is a vector denoted by ax. The vector y component is a vector denoted by ay. A vector contains two types of information. A magnitude is the length of the vector while the direction points. Vector direction can be given in various forms, but is most commonly denoted in degrees. Acceleration and velocity are examples of vectors.
Here is our example of vector components. A bus travels 25 kilometers on a straight road that is 30.50 degrees north of east. What are the east and north components of its displacement? So to answer this problem, the first thing we need to do is to catch our problem, and these are given value, which is A is equals to 25 kilometers and the angle theta is equals to 30.50 degrees. So to find the east and north components, let's solve for AX and AY. AX is horizontal components, which represents our east component. AY is vertical components, which represents our north component. So the formula of finding our east component is A cosine theta, and substitute our given value, which is 25 kilometers cosine 30.50 degrees, and it results 21.54 kilometers is, and the formula of our north component is A sine theta, and substitute the given value, which is 25 sine 30.50 degrees, and it results 12.69 kilometers north. So to check our answers, we'll use the formula for calculating the resultant vectors, since our resultant vectors is 25 kilometers and it's already in our given problem. So we'll use the Pythagorean theorem to find our resultant vectors. So to make our formula short, is r is equals to square root of ay squared plus ax squared, and substitute, which is r is equals to square root of 21.54 squared plus 12.69 squared, and it results to 25 kilometers. And to find the direction, we could use the SOHCAHTOA, or the inverse tangent equation. Tangent first to the power of -1 times 12.69 over 21.54, which results to 30.50 degrees north of east.